welcome to our fifth lesson on factoring polynomial functions. Today we're going to look at our second type of special factoring, that of perfect trinomial squares. They are trinomials that fit a certain pattern. Our first term is a perfect square, our last term is a perfect square, and the middle term is twice the product of whatever we're squaring here and here. Now that might be a little confusing when you start to think about it, but we'll see how this works out in our two examples. Once you establish that pattern exists, we can factor it into a binomial being squared. Now, if this middle term is plus, then this middle term is plus. If this middle term is minus, then this middle term will be minus. And that's the only other thing we might have to think about. So let's take a look at our first example. Here we have a trinomial. There are no GCFs here. So you might be thinking, why don't we use the strategy of the complex factoring strategy? In that case, we'd have to multiply 25 by 16, find out what that product is, and then come up with two numbers that actually multiply to give you that and add up to give you 40. When you deal with large numbers, there's a lot of different factors you have to worry about. But let's take a closer look and see whether or not it fits our pattern here. Is the first term a perfect square? It is. You square 5x to get 25x squared. Is 16 a perfect square? It is. You square 4 to get 16. And finally, is the middle term, I'm going to just bring down that plus, 2 times 5x times 4. So this middle term, you have to double multiplying this first term being squared and the second term being squared. So 2 times 5 is 10, 10 times 4 is 40, and this middle term is in fact 40x. So when we look at it, the first term is a perfect square, the last term is a perfect square, and this middle term fits this pattern here. Since it does, we can go straight to our final answer, which is a binomial that's being squared. What do we put on the inside? Well, whatever you square first comes on the inside, so we have 5x. Whatever you square last comes on the last term, or 4 here. The only other thing to think about is what sign goes here, and since this is a plus on our second term, we put plus right here. So a perfect square trinomial turns into a binomial that's being squared. Let's see one more example here. When I look at this, we have a trinomial, and we have a number in front, but it's not a perfect square. But don't forget, do we have any GCFs? We always want to keep that in the back of our mind. And 3 divides into 3, 24, and 48. So we could factor out a GCF of 3 first, which leaves us with 3 times n squared minus 8n plus 16. And just like we always do, take our GCF and bring it all the way down here so we don't forget about it. And then focus on n squared minus 8n plus 16 for a moment. Now there's a 1 in front, so we can use one of our other strategies for factoring simple trinomials, but let's see whether or not it fits our perfect square trinomial. Is the first term a perfect square? It is. You square n in order to get n squared. Is 16 a perfect square? Yes. You square 4 to get 16. And finally, is the middle term, I bring down this minus, is that middle term at 2 times n times 4. If it fits this middle pattern here, negative 2 times n times 4 is in fact negative 8n, which is what we want to have happen. If this pattern does not multiply to give you this middle term, you cannot do this special factoring strategy. You might have to try another strategy. But since the first term is a perfect square, the last term is a perfect square, and this middle term fits this pattern, doubling the product of the first and the last thing being squared, we know it's a perfect trinomial square. So then we make our binomial being squared, and the first thing you square is n, so it goes first. The last thing being squared is 4, that goes last. And because we have a minus in the middle, we put minus here. So our final answer should be 3 times the quantity of n minus 4 quantity squared. And hopefully, knowing that strategy will save you some time. Hopefully you enjoyed this. Have a great day.